Hello everyone, welcome to today's class. Today we are going to look at simultaneous equations. So before starting our topic, I would like to ask you a question. Can you think of any real life situation where two things needs to be true at the same time? Okay. How about you're logging to an online website and your verification code and the password needs to be true at the same time? Yes. So likewise, with equations as well, there are situations where two or more equations needs to be true at the same time. Such type of equations are known as simultaneous equations. So look at the equations here. We could have two or more sets, okay? Here we have two equations. They need to be true at the same time and we are going to solve it at the same time. Okay, so look at the first equation. I'm going to name it as equation 1 and the second equation as 2. Now look at the first equation, x plus y equal to 10. So what does it mean? Yes, if x and y are numbers, it means the sum is 10. So can you think of any numbers where the sum is 10? Yes, it could be 7, 3 or 8, 2 or 6, 4, isn't it? Yes. Now I have written this in ordered pair because there is an order for this solution. For x it is 7, y it is 3. So 7, 3 is an ordered pair. Okay. So we have found a number of solutions for the first equation. Now look at the second equation. X minus y equal to 2. So what does it mean? The difference of two numbers is 2. So, among the solutions for the first equation, can you find numbers whose difference is 2? Yes, 6 and 4. So, what can you say from this? 6, 4 satisfies both the equations. The sum is 10 and the difference is 2. So, 6, 4 is a solution for this simultaneous equations where x equal to 6 and y equal to 4. Okay. But it will not be this much simple in every cases. Okay, we can't do the trial and error method in every case, every equations. So we need a proper step-by-step method, isn't it? So let's go to the next example. Look at the example here. I'm also going to name it as equation 1 and 2. Okay. So look at the first equation. 5x plus 3y is 41 and second one 2x plus 3y is 20. So you can see that it is not that easy to use a trial and error method, right? So what we can do here? We can eliminate one of the variable. We can either eliminate x from both the equation or y from both the equation. If we eliminate x, what is left? Yes, what left is the y term and a number. So we get the value of y. Now substitute the value of y in any equation, you'll get the value of x. So our first step in solving this simultaneous equation is elimination. Okay, so I'm going to eliminate one of the variable by adding or subtracting the two equations. So when you look at the two equations, you can see that the y term 3y is same in both the equations. So what we can do is we can just subtract 3y so that we get 0 and the y term is eliminated. Okay, so what is left then? If y is eliminated, what left is x. So in order to eliminate y, I'm subtracting equation 2 from equation 1. Okay. So equation 1 minus equation 2. Okay. Why not equation 2 minus 1? Because if we subtract 1 from 2, we will get negative constants. Okay, we don't need that. So in order to avoid, we are subtracting a smaller number from a larger number. So that's why we have taken 1 minus 2. So we are subtracting term by term. So first 5x minus 2x would be 3x. 3y minus 3y is 0. We don't need to write that. Equal to 41 minus 20, which is 21. So 3x is 21. What is x then? Move this 3 to the right side. The operation is reversed. So multiplication would become division. 21 divided by 3, which is 7. So x equal to 7, we got the value of x. Now the second step we need here is substitution. Okay, substitute the value of x in any equation, either equation 1 or 2. So I'm going to substitute in equation 1. So equation 1 will become 5x. So 5 times 7, which is 35, plus 3y equal to 41. Now again, we are collecting the constants on one side. So we are moving 35 to the right. 3y would be 41 minus 35, which is 6. And y would be 6 divided by 3, 2. Now x equal to 7 and y equal to 2 is the set of equation. Now, let us say if we can have more than one set of solutions for this. No, there is only one set of solution, and you can see here that we needed two equations to find the value of x and y. So the number of variables is equal to the number of equations we will be needing to solve the simultaneous equation. Okay, so what you have learned today is simultaneous equations are two or more independent equations that share one or more variables, and they are solved at the same time with a single set of solutions. Okay, and there are two steps in solving the equations. First is elimination and the second one is substitution. Elimination means we are eliminating one of the variable term, either x term or y term, from the two equations. And substitution means we are substituting the remaining term, the remaining variable, by the value of the variable we have got. Okay, so that's the two steps in solving the simultaneous equations. So in the next classes we'll be coming with more complex equations. Okay, so that's about today's class. Thank you so much.